So welcome back to the first session of theory of computation, right? And the topic is basics of strings and alphabets. So I'm going to start with your first module of part 1. Under this, we will be covering few definitions, that is the basics of automata. The very first definition we are going to cover is, so first of all, we have objectives. So after going through this topic, you should be able to understand the basics of automata, define the various terms like strings, alphabets, languages, and grammar. Then you should be able to learn the different symbols which we are going to use for each term, like which symbol is used for string, which symbol will be used for alphabet, and similarly for language and grammar. So basics of strings and alphabets, we are going to cover 5 definitions. The very first definition is for alphabets, then we have strings, then we have languages, then we have grammar, last but not the least, that is problems, right? So I'm going to start with the very first definition, that is alphabets, right? So first of all, theory of computation is entirely based on symbols. These symbols are generally letters and digits. So an alphabet is a finite known empty set of symbols. So you should be able to understand first of all the term finite, right? Finite means we have some symbols, right? Your set is known empty, finite known empty set of symbols, and this alphabet will be represented with the help of this sign, which is called sigma sign. This symbol is called sigma symbol, right? So let's discuss with some examples. So first example you can see is, that is sigma is equals to 0, 1. So these are the examples of alphabets, but it will cover in the category of binary. As you all know, 0, 1 belongs to the category of binary alphabets, right? Then we have 0, 1, 2, 3, so on up to 9. These are your decimal digits, right? Then we have a set of ASCII characters, a set of ASCII characters, that is your special symbols from the keyboard: plus, minus, multiply, percentage, divide, any. You can write any special character from your keyboard, right? Then small abc, the set of lowercase letters, again it will be listed under the category of alphabets. Then we have sigma is equals to capital A, capital B, and so on up to capital Z. So again, set of uppercase letters. So this is the example of your alphabet. I hope the definition of alphabet is clear to all of you. I'm going to repeat it again one more time. Basically, an alphabet is a set of symbols which are known empty finite. Okay, finite known empty set of symbols. So it is represented by sigma, this sign sigma, finite known empty set of symbols, and you can see the various examples: 0, 1 binary alphabets, 0 to 9 decimal alphabets, right? Then we have set of ASCII characters, Small ABC, set of lowercase alphabets, capital A to capital Z, the set of uppercase letters. The next definition is for strings, right? As you all know, when we are going to talk in English, so first of all, you should be able to understand ABC, right? So first of all, you people will understand the concept of ABC. So in TOC, alphabets will be acting as your ABC, right? After learning the proper English, that is your 26 letters of English from A to Z, you people will be able to make one word. I hope the concept is clear to you, right? So after learning A to Z, you can easily form hello. You can easily write any word, Sandeep. You can easily write we met, right? So after alphabets, we have the second definition, that is strings. So a string can be defined as a finite sequence of symbols selected from some alphabet, right? Now you have to choose these alphabets. You have to choose these alphabets to make your strings, right? So it is denoted with the help of W. Alphabets will be represented with sigma. Similarly, string will be represented with the help of W, right? So the empty string is the string with zero occurrences of symbols. So this string is represented as epsilon or null, epsilon or lambda, right? If your string is empty, it will be represented with epsilon or lambda. So you can see some examples. So here you can see the single zero. So it is a example of string which has been taken from binary alphabets 1, comma, double 1, comma, double 0 and 0, double 1, 0, 1. Okay? So all these examples will be constructed with the help of binary alphabets. As you all know, we have two binary alphabets, that is 0, comma, 1, right? So you can make any string of your choice with the help of 0, comma, 1. Clear hai? I hope both the board and the PPT is visible to all of you. Ritika?
Yes, sir, visible.
Okay, done. So next example we have CAT, cat, right? Again, C capital, A capital, T capital. So this word is formed with the help of English alphabets and compute. So all these are the examples of strings, right? So again, if you are advised to make the number of strings taking 2 as a length, okay, over alphabet A, comma B. So how many combinations will be there? 4. If you will be asked to make all the strings over the alphabet A, comma B, over the alphabet A, comma B, whose length is equals to 2. So two combinations, for two combinations we will be having for two we will be having 4 combinations, that is The first string will be AA, next will be AB, third will be BA, and last but not the least, we have BB. I hope the concept is clear, right? If you will be asked for length is equals to 3 over A comma B, A comma B whose length is equals to 3, right? So how many combinations are there? 2 raised to power 3, that is 8. It will be starting from triple A to triple B. So all these strings will belong to this. So this is the definition for string. So next we have languages. The third definition is for language, right? So after reading, after getting all the ABC, you are going to make words. When you are clubbing up the words, you are going to make a sentence, right? In English. Okay? So in Automata, we have language will be acting as your sentences, right? So let's understand its definition first. A language is a set of strings of symbols from some alphabet. So let sigma be an alphabet and sigma star be the set of strings over sigma, right? So a language which can be formed over sigma can be finite or infinite, right? So it can be finite means it is having limited words, or it may be infinite, it is having unlimited words. That thing is called infinite. So let's understand its example first. For example, sigma is equals to 0 comma 1, then sigma star is equals to epsilon. Epsilon means zero occurrences of 0 comma 1. Epsilon means your empty string, right? If you are going to have these two alphabets, now you are going to make first of all the strings. So if you have zero occurrences, then you can write it as with the help of epsilon. If you have only 0, this is your string. If you have only 1, this is your string. If you have two combination 0 0 0 1 1 0 1 1, right? And so on, because here the length is not defined. I hope the concept is clear, right? Okay, then this is your sigma star. Then what is your L? So L is equals to 0 comma 0 0 comma 001. It is a language which is having only 3 strings, that is 0 0 0 0 0 1, right? All these strings will constitute one language. Okay, this is your string 1, that is S1. This is your W1, sorry, string 1, string 2, and string 3, W3, W1, W2, W3. So all these W1, W2, W3 will constitute one language, right? And in second example, you can also write it as L is equals to 0 raised to power n, 1 raised to power n. For n is greater than equal to 0, it is again a language. I hope the concept of language is clear to you.
सर रिपीट कर दो.
So first of all, the definition of language. A language is a set of strings of symbols from some alphabet. That is, first of all, we have some symbols from the alphabet, and with the help of those symbols, we are going to make, suppose this is your alphabet 0, 1, right? With the help of alphabet, we are going to make string. Okay, so 0, 1. So this is your one string. Then we have language 0, 1, 1, 0, 1, 1, 0, 0. Means after clubbing all the 4 strings, you are getting one language which will be represented with the help of L. A language will be constructed with the help of strings. A string will be constructed with the help of alphabet. Right? So here you can see that sigma is equals to, we have sigma is equals to 0, 1, and under sigma star, this is your loop, or you can say iteration. Star means more than one occurrence. Loop or iteration. So in your sigma star, we have first of all the 0 occurrence. For 0 occurrence, you will be represented with epsilon. Then we have a single string, that is 0, a single string, that is 1, then 0, 0, 0, 1, 1, 0, and so on, because here the length is not defined, right? So this is your sigma star will be of infinite length, right? Then we can say that your L is equals to any, you can write any strings 0, 0, 0, 0, 1. So this is a language which have been formed using sigma star, right? So in this language we have 3 strings. Similarly, in second part, L is equals to 0 raised to power n, 1 raised to power n for every n greater than equal to 0. So again, it is the example of language. So next we have grammar. So what is grammar? A grammar defines set of rules. With the help of these rules, valid sentences in a language are constructed. Okay? So constitutes of grammar. So basically we have 2 basic elements, terminal symbols and non-terminal symbols, right? All these small alphabets, small a, small b, small c, they are covered under the category of terminal symbols, right? And all the capital letters, they are called non-terminal symbols, or you can also call it as variables or auxiliary symbols, right? So these are represented with the help of capital letters, capital A, capital B, capital C, etc. Although a grammar is having a total of 4 tuples, but we will be covering all these 4 tuples in chapter number 4 later on, right? So you just need to understand the basic definition of grammar, and the basic definition says that a grammar defines set of rules. With the help of these valid rules, With the help of these rules, valid sentences in a language are constructed. So next definition is problems. So in theory of automata, a problem is the question of deciding whether a given string is a member of some particular language or not. Any question, right? For example, you all are studying in 7th semester, right? And we have roughly around 60 students in our class, right? If I am asking you roll number 1700248, is it present in your class? So your answer will be either yes or no. So I have asked you one question, right? So this is your problem. So more precisely, if sigma is an alphabet and L is a language over alphabet sigma, then the problem L is given a string W belongs to sigma star, decide whether or not W is in L. So let's see the example. So for example, we have L is equals to 0, 1, 0, 0, 1, 1, 1, 0 and 1, 1, 0, 1. Okay, right? So in this language, we have a total of 4 strings, right? Now my question is, you have to decide the W, that is W is equals to 0, 0, 1, 1, whether this string belongs to L or not, whether this string 0011. I hope the concept is clear to you. So your answer will be no, because 0011 have not been listed in this L. I'm clear?
Yes, sir.
Am I clear? So this is your problem. Any question, right?